Students, I am going to discuss a problem of kinetic theory of gases. The problem is a horizontal tube of length L, closed at both ends, contain an ideal gas of molecular mass m. The tube is rotated at a constant angular velocity omega about an axis passing through its one end. Find pressure at the free end. The pressure at the fixed end is equal to P1. Okay. So here you have given the tube of length L and the ideal gas inside. The pressure at this point, that is at this end, is P1. We have to find the pressure at this end, that is the free end. Okay. Now you take an element of length dx at a distance x, and the angular velocity of the whole tube is omega. So the angular velocity of this element is also omega. Now the pressure at this, here it is P, and at this end it is P plus dV. Okay. Now, so we can write by using Newton's second law. Using Newton's second law, that is net force corresponds to this F plus dF and corresponds to this is F. So A plus dF minus F is equal to dm, the mass of the element, omega square into x, as the element is rotated in a circle of radius x. Okay. Or here it is df is equal to dm omega square x. Okay. So df is equal to, or df is equal to this dp into a is equal to dm omega square x. Okay. Now we have to find the value of dm by using PV is equal to nRT. Using the relation PV is equal to nRT, we have here this P, the volume of the element is A dx. This is equal to number of moles dm upon the molecular mass. Here is dm over n RT. Okay. Or dm is equal to P A m upon RT into dx. Okay. Now you put the value of dm in this equation. We have this becomes now dp A is equal to dm P A m upon RT into dx, and here omega square x is. Okay. Now A get cancelled out from both sides. So or dp upon p, you take p on this side, so it will be m omega square upon RT x dx. Okay. Now integrating on both sides of the equation, here at x is equal to 0, the pressure is P1. At this end, the x barabar L, the pressure is P2. So integrating both sides, we have or ln P, limit from P1 to P2. This is equal to m omega square x integration, this x square P2. So it becomes 2RT. You put the limits, or ln P2 minus ln P1. This will be m omega square. Here it is L square upon 2RT. Okay. Now here it is ln P2 upon P1 is equal to m omega square L square upon 2RT. Okay. Now finally, or P2 is equal to P1 e की power m omega square L square upon 2RT. Okay.